Today's lesson is on literal equations. So what literal equations are, they are equations with multiple variables. And remember, variables, all they are the letters in our problems. So these equations are going to have a lot of letters. However, we're going to solve them the same way we've been solving equations for the past few days. So let's review solving the equation 2x minus 5 equals 13. So remember, the first thing we need to do is get rid of the thing that's not touching the x. So since 5 is being subtracted, we will add 5 to both sides. The negative 5 and positive 5 cancel, and you're left with 2x equals 13 plus 5, which is 18. So now we have 2 times x is equal to 18. To get rid of that 2, we do the opposite of multiplication, which is division. And 18 divided by 2 makes 9. We're going to solve this next one the same exact way, even though it looks extremely scary and different, but it's not, I promise. So this is ax minus b equals c. And I want to solve, it says to solve right here for x. So that means I want to get this x all by itself. So just like I wanted to get the x all by itself over there. So your first step, just like over here, would be to add the b, just like we added the 5. So we're going to add b to both sides. So negative b and positive b cancel. Over here on the left, I'm still left with ax. Now over here on the right, I really can't add the c plus b, right? Like those are not like terms. So I'm just going to leave it c plus b, and that's it. Then our last step, this is like a times x. And remember, when you're multiplying, to get rid of it, I don't want that a touching that x. So to get rid of something that's being multiplied, we divide on both sides. So I would divide both sides by a, and I'm left with x equals c plus b all over a. And that would be your answer. So notice, when you look between these two problems here, you're really doing the same thing. So the same math rules apply. We're just moving letters instead of numbers this time. All right, this next section says, identify the similarities and differences between the two equations. So, like I said, we're going to basically do the same math operations. So both of these equations, they both use opposite operations to isolate the variable. So what that means is, like on this first one up here, to get rid of that minus 5, I added 5. Same thing here. To get rid of this minus b, I added b. So regardless what you have, whether it's numbers or letters, you use opposite operations to isolate. The next thing is a difference. So a difference is that the literal equation, which is the one with the letters, think literal letters, they both start with L. The literal equation does not simplify nicely. In other words, we don't get it down to just like x equals one little thing, right? There's a bunch of letters there. And the reason this is because there's a lot of letters. And we can't combine random letters together. They're not like terms. So this is due to multiple variables or letters. All right, so let's do a couple. This first says A equals L times W, and it wants me to solve for W, which means I'm trying to get this W all by itself. So you need to think about what this problem is trying to say, or what does it say? It says A equals L times W, and I want the W all by itself, which means to get rid of the L in front of it, since it's being multiplied, I'm going to have to divide. So you're going to divide both sides by L. So you'd have A over L equals W. Did I get W all by itself? Yeah, I did. So W would equal A divided by L. Your next one says A equals B times H, and I want to solve for H. So I'm trying to get this H all by itself. So if I draw a line down here, again, this is saying B times H. To undo multiplication, I do division. I want the H, so I'm going to divide by the B. It would cancel out, and you'd be left with A over B equals H. Again, check. Did you get what they were asking for? Did you solve this to get the H by itself? Yeah. So we found that H equals capital A over B. All right, the next one says to solve for T. So I want to get the T all by itself. So the T is there with the R, and it's being multiplied with the R. So that's saying to do D equals R times T. Again, to get rid of something that's being multiplied, you have to divide. I want the T, so I divide by the R. What you do to the one side, you do to the other. I can't really do D divided by R, so I just leave it as T equals D divided by R. All right, the next one says I equals P times R times T. And I want to solve just for the T. So I just want to get this all by itself. Well, this is like saying, and I'm going to make this a little bit bigger. This is like saying I'm doing I equals P times R times T. They just don't put in all those multiplication signs. So everything's being multiplied, and I want this T by itself. So if whatever is being multiplied, I'm going to get rid of it by dividing, because the opposite of multiplication is division. And you can do that all at once. Cancel, 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 cancel. So T is all by itself, and it equals I divided by P times R. All right, the next one is very similar. So the next one says V equals L times W times H. And I want the H by itself. So I need to move everything except for that H. Since these things are all being multiplied, you'll divide both sides by the L times W. Again, this is because these are being multiplied. And to undo multiplication, we divide. So everything cancels. So H equals V divided by L times W. All right, this next one, it says to solve for R. So we have A equals pi times R squared. So I'm trying to get this R, oops, that doesn't look good, huh? I'm trying to get that R all by itself. All right, so we have a couple things going on here. We're gonna have to do two different things. Pi is just a number. That's like saying, I'm going to write over here, that's like saying if I had A equals 2 times R, right? Pi is just a number like 2, and I would divide by 2 to get rid of it. Okay, so we're going to do the same kind of thing here. Since pi is just a number, we know it's 3.14, we're going to divide both sides by pi. Okay, so pi divided by pi cancels. Now, you are left with, let me erase this over here. Now we're left with, I'm going to rewrite our problem. A over pi equals R squared. I'm still trying to get that R by itself. So to undo a square, we take the square root. So when we take the square root, our square root and our square cancel each other out. Those are opposite operations. So the R would be all by itself. Now on this left side, that's just going to be my answer. I'll leave it A, the square root of A divided by pi. And that's your answer to number 6. All right, for number 7, we have m equals c minus s. And I'm trying to solve for c. So I need to get rid of that minus s. It needs to go away. I want the c all by itself. So the first thing you're going to want to do is do the opposite of subtraction, which is addition. So I'm going to add s over here. Minus s and plus s cancel, so I am left with just c. Now I can't really add m plus s, so this is just going to stay c equals m plus s. All right, last example here. It says d equals m divided by v. And I want to get the m by itself, which means I better get this v away in order for the m to be by itself. So I said we read that m divided by v. The opposite of division is multiplication. So to get rid of that v, I'm going to multiply both sides by v. Those will cancel, and now I'm left with just m. Over here I have v times d. I can't really do anything with that, so that'll just stay v times d. So m equals v times d. And this concludes the video on literal equations with one step. Tomorrow we will continue this, but it'll take multiple steps to solve these problems.